All right, guys, so there was a question on homework problems number 13 and 14 from 1.4. So we look at number 13. Now we're trying to find the area given the vertices. The first vertice was at 3, 1. This is point E. The next one was at 3, negative 2. And this is point F. And the last one was at negative 2, negative 2. And this here is point G. So when we look at this here, we have a triangle. Yes? Now, the area formula for a triangle, area is equal to 1/2 base times the height. Now, as we talked about this yesterday, a height is we can take one of the vertices and drop a straight line down to the other side. Now, for the most part, and we'll look at the next one here, I have a feeling they're going to use all of the heights to be one of the sides, because this here ends up being a right triangle. So the height will make a right angle with the other base. And it works out that it is on a straight line, so we can count 1, 2, 3. And this is the base, 1, 2, 3, 4, 5. So the area formula here would be 1/2 of 3 times 5, or 5 times 3, because multiplication we can multiply in any order. So we can do this here. Well, 3 times 5 is 15, and half of 15 would be 7.5. So the area for this triangle would be 7.5. Any questions on this here before we look at number 15? Or 14, sorry. This is homework problem number 13 from 1.4. Okay, good. Now, number 14 was at negative 3, 4. 4, 4, and 3, negative 3. Yep. Yep. So I see what they're doing. So most of these here, the way that I showed you guys is the way to find the height of the triangle. Now, here, we can't quite say that this line here is the height, but we need a line going straight up and down from a vertice to a side that makes a right angle with that side. That is going to be the height. Now, we can't use this point here because we can't really make a line going to this side, to the side opposite, and have a right angle. We can, but most likely it might be somewhere up here or somewhere in between. It wouldn't be a nice straight line. We could do it with this one here and come this direction, but do we know what that location is? No, we don't know what the points of that spot are. I don't know the exact values where that would intersect. But with this blue line here, we do know the distance, even here, because this here is the point 3, 4. And this down here is the point 3, negative 3. So I could use the distance formula from there to there, or we can count. 1, 2, 3, 4, 6, 7. And the side that this connects to and makes a right angle is the base, which would be up here 1, 2, 3, 4, 5, 6, 7. Well, the base and height are both 7. Now again, at this point here, we could type this whole thing into the calculator to get to the answer, because we can do 1/2 times 7 times 7. Well, 7 times 7 is 49. And then we need to divide 49 by 2. 24.5 or 24.5 would be the answer. So this one here, the two side lengths didn't give us what we needed to be able to find it. Now, we won't necessarily cover this formula in this class, but there is such thing as the Heron's formula, which will solve for the area of any triangle, no matter what it is. And it is set up in pretty much it's the three side lengths added together divided by 2 gives us a certain value, S. And then for the area, we take the square root of S times S minus A times S minus B times S minus C, and it would actually give us the overall area of the triangle. But that's above and beyond what we'll do in here. We don't normally cover that in geometry. We'll cover it in algebra 2, not algebra 2, trigonometry is normally where that's covered. But it will give us the area of any triangle, no matter what state or setup that it is. Now, before we move on, are there any other questions on the assignments? Anything we want to look at? Huh? Okay. So I believe this is where we picked up or left off on the notes from yesterday. Yes? Okay. So let's look at this here. Let me put the Chromebooks away for now. You can just sit it over on the next to you, just so it's not in front of you. Looking at this here, given that EFG is a right angle, EFG. So what does that mean EFG's angle measure is? 90. If it's a right angle, it's telling me that it's 90 degrees. Find the measure of EFH and HFG. We want to find these two angles. Well, according to our postulate yesterday, the angle sum postulate, well, those two little angles will add together to give me the whole thing, yes? So what did we say the measure of the entire angle was? So 90 is equal to, well, this angle here, which is 2x plus 2, plus the other angle, which is x plus 1. So those two angles add together to give me the whole. But we don't have to do anything with 90 yet. But what can we do at the other side? Yeah, 2x and x are like terms, yes? So we can add those together. 2x plus x is? What else can we do? 2 and 1. We can add those together, and that gives us plus 3. We just combine like terms. We add them together. Since they're on the same side of the equal sign, we can just add those together. We don't have to do opposite operations. We don't have to do if it's positive, subtract. If it's negative, we add, unless we're trying to go from one side of the equation to the other, unless we're trying to move something across the equal sign. Now, what can we do next? Minus 3. Why would we not minus the 3x? Right, we're trying to solve for the value of x. We're trying to get it by itself, yes? Well, I do have 3x plus 3 on one side. Do I have 3x over with the 90 or any x's with the 90? No. Would it be wrong to subtract 3x at this point? Well, no. We would eventually get to the answer. It would take more steps. But it wouldn't be a wrong thing, because we could subtract the 3x from both sides and then subtract the 90 and move it to the other side. That would be fine. But here, 90 minus 3 is 87. And then we would divide both sides by 3. We're done. What do we need to find? Two equations. Is anybody still copying this down? Okay. I'm going to go on and erase it so I have a little bit more space. So why don't we do x plus 1 first? Because we said x is equal to. So the measure of angle HFG, well, it's said to be x plus 1, yes? So that would be 29 plus 1, which is? So the measure of angle HFG is 30. Mm-hmm. It's supposed to be an open circle. Open. Mm-hmm. It's almost like if you've seen, like it's going to be 80 degrees today, how they'll do 80F and then an open little circle. That's still degree. Now we need to find the measure of angle EFH. How can I go about finding it? Well, yeah, so 90 minus 30 is what? 60. So if I did 2 times 29 plus 2, I'm expecting this to give me 60. 2 times 29 is 58. Plus 2 is 60. I am not, if you like the way I have it set up here where we plugged it into both, awesome. If it makes sense that the fact that the one of them is 30, and we know the total is 90, 90 minus 30 gives us 60, that works too. Either one of them will work. And whenever we add these back together, we should get back to 90. So 30 plus 60 is 90. These are the correct answers. Questions on this here? Now, one thing I will caution is if you did 30 and then subtracted it from the total, and this wasn't the correct answer, it wasn't 30, they will still add up to be 90. So it's sometimes good to just, if you're not sure it's the right answer, go on, plug it into both and see what answers you get, and if they add up to be the total. Any questions on this here? Okay, I'm going to throw that over there. Using a bisector to find angle measures. Now, what did we say about a line segment bisector? It did what? In? Because it did something special. Because when we had a segment bisector, a ray, a line segment, or any of those in particular, what did it do to the segment as a whole? It cut it in what? Half. It cut it in half, right? Because then we knew that the two segments that it split it into were equal to each other, because they were congruent, yes? So if I talk about an angle bisector, what is it doing to the angle? It's cutting it in half. When we talk about bisecting, we're talking about cutting something in half into two parts. And when we talk about angle bisectors or segment bisectors in geometry, we're talking about cutting it exactly in half. So when we look at this here, it says that ray QS bisects the angle PQR. So that means it cuts it in half, yes? Okay, that might be helpful. Angle PQS is 24. They filled it in. What's this other angle down here? It's going to be 24 degrees also because it cuts it in half. It's going to cut it in half. So one of the smaller angles is 24, the other is 24, so what would the whole thing be? 48, because we can add those two to. That's it. Questions on this here? VB bisects angle AVC, and the measure of angle AVC is 158. Find angle BVC and the measure of angle AVB. So VB bisects it, so it cuts it in half. AVC, the whole angle is 158 degrees, yes? And what did we say this did? It's a bisector, yes? So it cut it in. So what can I do? And what do I get? So the measure of angle AVB is going to be? How about the measure of angle BVC? It cut it in half. It cut it into two congruent parts. So they will be equal to each other. Any questions on this here? Yes. That's fine. So on the back sheet, you don't have to write all this. Just copy the angle itself down. It doesn't have to be precise, as long as it looks something close. Now what we do know is that BD is an angle bisector. It bisects the angle. Yes? So that means that ABD, really we're saying that the measure of angle ABD is equal to the measure of angle DBC. So why did I use the equal sign there, not congruent sign? Because what does the little m mean in front of the angle? Measure, right? So if I'm talking about a measure, I'm talking about what? A value, isn't it? Because it's talking about the value of that angle. So are we actually talking about the angle itself? Well, no, I'm talking about its measure, right? Its length or its degree. So really, both of these here are numbers, yes? And when we talk about numbers, we talk about them being what? Equal, yes? If we were talking about the angle itself, the actual angles, so the physical angle of this here and this here, then we would use congruence. But because this is just the number, the value of that angle that's a measure, we'll use equals. And it's also dealing with the fact that it did bisect it, because their measures are going to be the same. Do I know the measure of either one of these angles? Do I know the measure of the whole angle? No, they didn't give us any numbers, did they? They gave us two equations, or two expressions, but we don't need the whole thing, because I know that these two are equal to each other, yes? So that means 8x plus 35 is going to equal what? So I do know this. So if I want to find out what the measure of each angle is, I just need to solve for the value of x. Because if I know what x is that makes these two equal, we can plug it back in and find the actual angle. That will work just fine. Because we can subtract 35 from both sides first. Because here 35 minus 35 would be 0, leaving us with 8x. We still have 11x. Now 23 minus 35 will be negative. And then what can we do? We would want to do that, but since there's the equal sign between them, we can't just add them. Yeah, we'll have to subtract 11x from both sides. I think that's what you're going to say, Janessa, right? 11x minus 11x would cancel. 8x minus 11x would be negative 3x equals negative 12. And then we would? So we divide both sides by negative 3. Does negative 3 divided by negative 3 would give us 1. The negative and negative would make a positive, because they only change when either we subtract the negative or multiply or divide by two negatives. So we get x is equal to 4. Which equation do we want to plug it back into? Well, expression, sorry. Which expression do we want to plug it back into? ABD. 8x plus 35. Well, 8 times 4 plus 35 is what we would have, because the value of x is 4. 8 times 4 is plus 35 is, so the measure of this angle is 67 degrees. What's the measure of the other angle? So either one, and we could write it out, erase that there, that the measure of angle ABD is 67 degrees, or the fact that the measure of angle DBC is equal to 67 degrees. Now what's the measure of angle ABC? Because it'd be these two added together, yes? Well, 7 plus 7 is 14. 6 and 6 is 12, plus 1 is 134. I mean, we can do these addition, subtraction, multiplication. We can do these in a calculator. We don't have to do these in our head. Any questions on this here? Any questions on anything we've done so far today? Do we want to see another example of an angle bisector with equations? Huh? We good, Anthony? Okay. Here's your assignment for this here. On page 41, problems 3 through 12, 21 through 26, 33, 34, 37, and 40. Are the problems for this assignment here. Now, tomorrow we will do 1.6. I'll have to update the schedule because I'll try to keep that chalkboard up to date with what we're doing. Once we finish 1.6, we will have a makeup day, which would be Thursday. And then Friday is going to be the review day. I will give you the review sheet on Thursday so you can have it and get started on it. So you'll have Friday's main thing is going to be working on that review sheet because, again, we're going to have a virtual day Friday. I want you to spend that time working on that review sheet and getting those done. I will, for your attendance, I'm going to pick 4 randomly from that entire review sheet. You just need to, for attendance, have a picture or something to where I can at least somewhat read it, showing your work on those problems, okay? So you're going to want to do pretty much most of it, and I'll go over the review sheet again later when I hand those out. But for your attendance on Friday, you need to submit in Google Classroom those 4 under that assignment for attendance to be counted present. And then when we come back from the break on Tuesday, we will go over the review sheet. I will go over all those problems. So any of them that you have questions on, we will go over those. And your test will be a week from tomorrow over Chapter 1. And we are going to move on to Chapter 2.